Orthographic projections. So in this orthographic projections, first we will define what are the objects behind it, applications, etc.
Learning objectives. After completion of this chapter, you will be able to know the meaning of orthographic projection, know the various views of an object obtained in projection, drawing the front, top, right side and left side views, classify the visible and invisible parts.
Now we will explain what are the applications in industrial and machines, etc. We will observe.
Engineers are mainly involved in the design, development and manufacture of machines and other engineering structures. Whatever this may be, the very first step is to prepare a drawing of the machine or structure to provide the details of the design like the shape, the size and so on. To have complete representation of such a three-dimensional object in the drawing, the object is viewed from different directions. These are typically the front view, the top view, the left side view and the right side view. And these views are called the orthographic views of an object.
Now discuss about introduction of orthographic projections.
Introduction. Engineers are mainly involved in the design and development of machines and structures. To communicate all the detail of a machine structure, engineers must prepare a drawing that shows the true size and shape of the entire machine structure. It is difficult to represent the three-dimensional object exactly on a sheet of paper by showing a single view. Hence, a set of views from different positions are prepared to define the object completely. Though different methods of projections are available to obtain the views of objects, the orthographic projection is used for most engineering purposes.
In this, the subtitles are Introduction, 3D visualizing module and types of projections. Now let us go to the introduction, projection definition.
Projection. Definition. The views of an object projected on an imaginary plane by viewing it perpendicularly from the front, top or side of the object are called as projection. The various views obtained in projection are as follows. Front view of an object. The view of an object projected on a transparent plane by viewing it perpendicularly from the front side of the object is called its front view. It can also be called as elevation. In general, the front view of an object FV is taken as the view normal or perpendicular to the longest edge of the object.
Now you assume this is an object, and for this it is the front view, and it is the side view, and it is the top view. Next, go to top view definition.
Top view of an object. The view of Top view of an object. The view of an object projected on a transparent plane by viewing it perpendicularly from the top side of the object is called the top view of the object. It can also be called as plan. Side view of an object. The view of an object formed on a transparent plane by viewing it perpendicularly from the side is called the side view of the object. The view projected from the right-hand side of the object is called the right side view. Similarly, the view from the left-hand side is the left side view. Various views are referred with respect to a fixed position called as position of observer.
Now visualizing modules. Let us consider primitives. In these primitives, let us take this object, and the object, it will be visualized in 3D view, and in that front view is like this. Similarly, top view, side view, and perspective view. Now next object, we will consider this one. It will be visualized in 3D as a front view, and the top view, side view, perspective view. Next we will consider this object. For that, front view, top view, side view, perspective view. Now let us consider this object. Front view, top view, side view, and also perspective. For all are side. Now let us consider prisms. In this prism, first you consider this type of figure. For that is 3D front view will be visualized as this front view, top view, side view, perspective view. Next, let us consider this type of object. Front view, top view, side view, perspective view. Now let us consider this type of object. It will be visualized in 3D, front view, top view, side view, and perspective view. Let's consider this object. In 3D, visualize front view, top view, side view, and perspective view. Now next, pyramids. In this pyramids, first you have to consider this type of figure in which front view, top view, side view, perspective view. Let us consider this type of figure front view, top view, side view, perspective view. Let us consider this type of pyramid. For that, front view, top view, side view, perspective view. Now last one, for this pyramid, front view is like this, top view, side view and perspective view. Now next, blocks 1. In the block, as shown the figures one by one, let us see what are the views regarding the blocks. This is the block. So for this block, front view, top view, side view, perspective view. Now let us consider like visual box block. For this front view, like this, top view, side view, perspective view. Now let us consider this example. For this front view, top view, side view and perspective view. Let us consider this type of figure. For that front view, top view, side view, perspective. Let us consider second block. For this block, front view, top view, side view, perspective view. Block second. For this block is the front view, top view, side view and perspective view. Let us consider this block. For that, front view, top view, side view, perspective view. Let us consider for this block will be front view, top view, side view, perspective view. So these are all the views of primitives and prisms, pyramids and the blocks regarding. Now next, types of projections. Types of projections are two, pictorial projections, orthographic projections. In this pictorial projections, the investor would like to visualize the finished product as it would appear in a photograph. The customer also wants to visualize how the machine component or house will look like with its realistic image. It is very difficult to understand the description of object in orthographic projection. This requires the representation of the three-dimensional of object in a single view. To view the solution to above pictorial view is only the solution. In the pictorial view, the object can be visualized more realistically. In engineering, pictorial projection is very often resorted by architects and engineers. Pictorial drawings are obtained by the projection of required object, and single plane generally used methods to obtain pictorial projections are as follows. There is isometric projection and perspective projection. Now next, orthographic projections, in which you discuss this one.
Orthographic projection. Introduction. Ortho means at 90 degrees and orthographic, right angles drawing, means the view is obtained by projection at 90 degrees. The projection of the object are perpendicular to the plane of projection on which the projection is obtained is known as orthographic projection. Imaginary rays of vision from an observer's eyes viewing the object from an infinite distance. The rays of vision is parallel to each other and perpendicular to the object in projection plane. These rays are called as projectors.
The four quadrants. When the planes of object projection are extended beyond their line of intersection, they form four quadrants, as shown in the figure. These four quadrants are named as first quadrant, second quadrant, third quadrant, and fourth quadrant, moving in the counterclockwise direction. It is conventional to rotate the picture planes and bring all picture planes on which views are obtained on a single plane. Let us consider the four quadrants. In this x and x axis and y axis, it will form with reference line the vertical plane and the horizontal plane. Now next, vertical and horizontal planes. Vertical and horizontal planes. The picture planes that are used to obtaining orthographic views are customarily called principal planes of projection or the reference planes. The plane in front of observer is the vertical plane, is denoted by VP. The other plane which is similar to VP is called horizontal plane, is denoted by HP. That is, XY is the reference plane, HP horizontal plane, VP vertical plane. Now in this, give the explanation vertical plane and horizontal planes. To obtain projections on drawing sheet, it is convenient to rotate the HP through 90 degrees to clockwise direction about the reference line XY so that it lies in extension of VP as shown in figure. The front view of object is obtained in a VP. Its top view is obtained in HP. If the object lies in first quadrant, now let us look in now next first angle projection. First angle projection.
First angle projection. When an object is situated in the first quadrant, the projection obtained is called the first angle projection. In this projection, the object lies between the observer and the plane of projection. The object is situated above the HP and in front of the VP. The front view of the object comes above its top view with respect to the reference line.
Position the solid in the first quadrant. Position the solid in the first quadrant. Look at the solid from the front. To obtain the front view as shown in the figure, look at the solid from the top. To obtain the top view as shown in the figure. Rotate the horizontal plane 90 degrees clockwise to get the projection. Now the required projections are obtained.
Once again,
Position the solid in the first quadrant. Look at the solid from the front. To obtain the front view as shown in the figure, look at the solid from the top. To obtain the top view as shown in the figure. Rotate the horizontal plane 90 degrees clockwise to get the projection. Now the required projections are obtained.
now third angle. And projection symbol. It is mandatory that the system of projection used, namely first angle or third angle, should be symbolically specified in a title block. These symbols are the two view of frustum of a cone whose axis is horizontal. In first angle projection, the top view comes below the front view, the left side view to the right, and the right side view to the left of the top view. Both in third angle projection, the top view comes above the front view, the left side view to left to the right side view to the right of the front view. The symbol for first angle and third angle projections are shown in figure. Like this. next, profile planes. Profile plane. We have seen that front and top view of object are obtained on vertical and horizontal planes respectively. However, depending on the clarity of information to be provided by drawing, quite often other views, namely the side views, are also drawn. The views taken from the rear bottom sides, left and right, are also to represent the geometry of the object. The side views are obtained in third plane called the profile plane. The three planes, namely the horizontal, vertical, and plane profile planes, are mutually perpendicular to each other. The views obtained on these planes are called as principal views. Now let us observe front view, left side view, top view, which will be planes are appear as a horizontal plane, vertical plane, and it's their movements also as shown in figure. Front view, top view, left side view. Now next, consider general procedure. In this general procedure
for preparing the orthographic views. You may be required to prepare the principal view for a given component, maybe a machine part, a building section, or an electronic component. To prepare the principal views, the steps given below are to be remembered. First, study the given object and understand various features. Study the dimension and find out what would be the overall length, width, and height of the views to be prepared. For the given component, select a suitable viewing direction, if not given, from which you will obtain the front view. Select the other views which will be necessary to give a full information about the object. After finding the space required for this drawing, give suitable spacing from the neighboring drawings and start preparing the present drawing. Depending on the size of the drawing, suitable spacing may be provided between the views. The spacing should be enough to accommodate the dimensions to be marked later and also to contain the view name. The view drawn should be in proper vertical or horizontal alignment. Points can be projected from the front view to the side views or vice versa by drawing horizontal lines. In order to project the desired points from the top view to the side view, use the 45-degree line called as the meter line. This line is drawn at 45 degrees from the intersecting point of the reference lines X, Y and X1, Y1 as shown in figure. After preparing the drawing, give all important dimensions and other legends and notes. Print the name of view also. The invisible parts of machine components are drawn by thick dotted lines. In order to project the desired points from the top view to the side view, use the 45-degree line called as the meter line. This line is drawn at 45 degrees from the intersecting point of the reference lines X, Y and X1, Y1 as shown in figure. After preparing the drawing, give all important dimensions and other legends and notes. Print the name of view also. The invisible parts of machine components are drawn by thick dotted lines.
Now let us consider isometric views to orthographic views. Example number 1. If this is a figure, for that is the top view, side view and front view. Example number 2. If this is an object or figure, for that front view, side view, top view. Next, 3. For the figure, top view, front view and side view. For given this figure, front view, side view, top view. Next, if the figure is like this, front view, side view, top view. Front view, top view, side view. For this given figure, front view, side view, top. For given figure, front view, side view, top view. For given figure, front view, side view, top view. Given figure, front view, side view, top view. Given figure, front view, side view, top view. For given figure, front view, side view, top view. For given figure, front view, side view, top view. For given figure, front view, side view, top view. Given figure, front view, side view, top view. For given figure, front view, side view, top view. Given figure, front view, side view, top view. For given object, front view, side views. Similarly, top view also same, front view. Similarly, front view, side view, top view. Front view, side view, top view. Next, isometric views to orthograph problem number 1. It's like this. Problem and solution is given. Front view, side view, top view. Now next one, problem number 2. The given figure, front view, left side view, top view. Problem number 3, figure and its right side view, front view, top view. Problem number 4, in which figure is given for the right side view, front view and top view. Once again, the previous views will be repeatedly. We will see how it will be viewed in isometric views to orthographic views. This is the isometric view, and the remaining front view, top view, left side view are the orthographic views. Problem number 2. Three, four, now let us evaluate the how we will little bit of understood regarding self-evaluation method modules. In orthographic rule, evaluation is known as front view, and next second, the rays of sight from observer perpendicular to the picture plane called or the projections, not projectors. It's a projectors, not projections. Now next, plane perpendicular to both vertical and the horizontal plane is called horizontal plane, vertical plane, profile plane, none of that. Maybe it is profile plane. Similarly, fourth one, the view obtained by looking at an object from its front is called the bottom view, plane view, front view. The view obtained by looking at an object from its front view called front view. Now next, in orthographic projection, it is imagined that the observer looks at an object from an angle of 45 degrees, an angle of 30 degrees, an angle of 60 degrees, and infinite distance. Maybe infinite distance. Next, sixth one. When the object is assumed to be situated in third quadrant, the system is used first angle projection, third angle projection, fourth angle projection. Maybe it is in third angle projection. When object is situated in first quadrant, the projections conform to the first angle projection. Now next, in first angle projection, the front view comes above the top view. Next, the system of projection in which the top view of object is drawn below its front view is the third angle projection, first angle projection, none. Front view is the first angle projection. Now next, the principal planes are HP, VP, both HP and VP. Now this way we can evaluate the self-evaluation. Now, in examination questions, first you note down exercise, draw orthographic views, that is front view, top view, left side view, right side view of a machine elements given below. Example number 1, number 2, number 3, number 4, number 5, number 6, number 7, number 8, number 9, number 10, number 11, number 12, number 13, 14, 15, number 16. So these are very important, and which are all the orthographic projections comes in the previous examinations questions. So in this way, we will learn the orthographic projections, this which will give the most importance in a engineering drawing and machine structures, which will it will be used in machine structures, and industrial machines will be viewed with this background of orthographic projections. Now we will close this. In next class we will continue the continuation of E lesson.